don't just send it back and copy down. Okay. Next. Question 3b. Right? What Ethan has given us is that in the numerator, to factorize this, okay, it got c minus 3d. Not sure whether you can see from the back. Okay, this was its factorization. Alright, so to get the numerator's factorization, we need to recognize that this is quadratic. Okay, I'll erase this part so that we can use the board here. Okay, so since it is quadratic, we do our cross method. We have c squared here minus 15d squared plus 2cd. Okay, c times c give us c squared. To get 15d squared, ignoring the minus sign first, I consider 5d and 3d. For which when I cross multiply, I will get 5cd and 3cd over here. And to get positive 2cd, it must be positive and negative, so positive and negative. Okay, so that's why we get this factorization on the numerator. Then in the denominator, okay, 4c squared plus 20cd, we have 4c times c plus 5d. Okay, when we factorize out 4c, then after that, you notice that earlier on, Ethan's working was such that he just cancelled like that. Okay, I did not teach you how to do the cancellation because I don't really want to encourage the idea of cancellation. Especially when we go up to higher levels, you will realize you cancel a lot of things and then some of the handwriting can be very messy. You tend to forget some things. Okay, you can do cancellation, but if you want to, I recommend that you do cancellation using pencil. Okay, so that there's that contrast, easier for us to observe what is still there, what is not there. Okay, so we are essentially dividing c plus 5d on the numerator and denominator. So we get an answer of c minus 3d over 4c. Okay, so that will be the answer. Right, then what John has given us, okay, to simplify 3a minus 6 over a squared plus a minus 6. In the numerator, we have 3 times a minus 2, okay, when we factorize out the 3. And in the denominator, we did being quadratic, you do your cross method also. A squared minus 6 plus a, you can get 3 and 2. Okay, 3a and 2a, so positive, negative, positive. Okay, so that will be the correct factorization. Then we divide away a minus 2, so cancelling this away, we get 3 over a plus 3. Okay? Right? I'm not that insistent on you having to show the divide. Okay? So you want to cancel also can. Right? Because moving forward, you once you get the hang of it, okay, I will do more of the cancellation part. Okay, I'm just trying to get us understand it's about division. Making sure we get the concept right. Okay? Now let's look at the question that Joshua was struggling with. Okay, so 3x minus 3y. Okay, partially correct. Say that we factorize out 3 times in order to get 3 times x minus y. So the numerator is correct. But the problem is in the denominator. Denominator we have ax minus ay minus x plus y. I told him that we need to factorize by grouping. Okay, so observing this pair over here, ax minus ay. We factorize out the a, so this is also partially correct. The problem here is, okay, in the next part, we have minus x plus y. Okay, we know that if I leave my answer like that, it is not helpful for us to extract out a common factor. Okay, so how am I going to extract out common factor? We see that there's x minus y over here. Now here also got x and y also, but it's not x minus y. Okay, but if I let's say want to put brackets. Okay, can I put brackets like that? Between this step and this line over here. Okay, can I put brackets over here to name it the equal thing? Name it the same? No, right? Because if I want to open up the brackets, the minus sign will affect x, the minus sign will also affect y. So when I open up the brackets, essentially it becomes minus x minus y, which is not equal to the original, which is minus Okay. Then we see that we can factorize out the x minus y. And then what is left is a minus 1. Remember there's invisible 1 over here. So a minus 1. Okay. And then we get 3 times x minus y on the numerator. Right? So the common factor to divide is actually our x minus y. Okay, so our x minus y disappears. Right? And then we can get 3 over a minus 1. Okay. Questions? Right? Points first. I know that it's been a while since I gave points because we were on graph. So Trixie, Ethan, John, and then Joshua points. Huh? It's not complete one. I gave you the answer one there. Okay. Now let's look at practice now 3. Question 2 in your textbook. I left this out from the SLS lesson because I thought that it would be rather challenging for me to go through this over a video. Because this is not something conventional, not something that we have been doing. We have what? We have n to the power of 4, right? And then minus 5n squared plus 6. I think I need us to agree that our numerator is not quadratic, because quadratic means power is 2. Okay, highest power is 2, right? The highest power now is 4. Okay, so this is not quadratic. Okay, so it seems that we cannot do our cross method. Okay, it seems like it, right? Then after that, our denominator also n to the power of 4 minus 9. Also seems like, okay, very close to our a plus b, a minus b, okay, a squared minus b squared, but it is power of 4, not power of 2, right? Okay, so how? Okay, the thing here is that I want us to agree that n to the power of 4 is n squared to the power of 2. Why? Okay, that's because, erase this. What is n to the power of 4? It is how many times of n? Repeated multiplication, right? Of n 4 times. Right? N times n, it is n squared, right? Okay, and then the other n times n over here, also n squared. Right? So isn't it right for me to say that this is a repeated multiplication of n squares, so n squared to the power of 2. Agree? Agree? Okay? So therefore my n to the power of 4, I write it as n squared to the power of 2. Okay? Then after that, minus 5n squared plus 6. Likewise, in the denominator, I also rewrite my n to the power of 4 as n squared to the power of 2 minus 9. And we know 9 is 3 squared. Okay? So what do we see over here? Right? If let's say, okay, I just do a little bit of tweak over here first. Okay? Let's say I let my n squared be a star. Star. Does my numerator now look like it is something quadratic? Okay, maybe you don't like a star, you want to replace it with a letter also can. Does it look quadratic? Can we do our normal cross method already? We can, right? Okay, and then our denominator, okay, does it look like our usual a squared minus b squared? It does, right? Okay, so we can also do our a plus b, a minus b. Okay, so this is a little trick behind solving this question itself. Okay, we need to understand what does n to the power of 4 means then be able to rewrite it this way. Okay, so that I can make it manageable for us to do our cross method and also our identity a plus b, a minus b. Okay, so from here I'll continue. I'll erase this color. Okay, we do our cross method. Okay, so if let's say you want to keep to this rather than writing it this way, how would I write it? I will write it as x squared plus 6 minus 5x squared. So it's the same way, same arrangement. Okay, the quadratic one, power of 1 over here, constant term here, okay, the one with x squared over here. Right? So we are looking at x squared times x squared, get us x squared to the power. And then 6 is 3 times 2, give us 6. Cross multiplying, I'll get 3n squared, 2n squared. Only possible when both are negative. Add up to give us negative 5n squared. So negative, negative. So therefore, in my numerator, factorize it, I'll get n squared minus 3, n squared minus 2. Okay. Now, denominator. Okay, Joshua, let you redeem yourself. How to factorize the denominator? I'm trying to use the idea of a squared minus b squared. What is the factorization of a squared minus b squared? The formula is strategy. Okay, so you found that a squared minus b squared is a plus b, a minus b. Then how do I apply it in this case? N squared plus 3, n squared minus 3. Very good. And back to your seat. Now that we have done that, what is it that we can divide away in the numerator and denominator? N squared minus 3, right? So, okay, we can divide that away. Okay, have cancel it. And then we will get n squared minus 2 over n squared plus 3. Okay. Questions? Any questions? Before I move on? Yeah. Why cannot take out n squared in the numerator, is it? Final answer. Or why cannot divide away n squared? Okay, I think that's a good question. Okay, so JJ asks, why is it that I cannot further simplify? Maybe let me erase this part of the whiteboard. Okay, so JJ is thinking that we divide n squared or take it out or remove it, okay, such that the answer is going to become negative 2 over 3. Okay, that is his idea, his thinking, right? Which I think some of us may actually have that idea as well, right? But remember, what is the thing that we are relying upon when we do this cancellation? Okay, the correct method is that we're trying to divide by a common factor across everything. Okay, now this numerator over here means that I have this group of things multiplying with this group of things. Okay, it is like a 2 times 3. And then after that, your denominator is also 2 groups of things multiplying each other. For example, maybe 4 times 3. Okay, and then because there is a common factor of 3, we divide both by 3 on the numerator and denominator. Okay, and we know that times 3 divided by 3 gives us 1. So that's why the 3 is being removed to give us 2 over 4 in the end. Okay, and that's why we get n squared minus 2 over n squared plus 3. But what Jishin is now thinking is that, okay, I want to divide by n squared denominator. Can I do that? Down here is a -2. It's not multiplication. Okay, so in contrast, if I have 2 plus 3 over 4 plus 3, and I want to divide by 3 on this entire numerator, and then divide by 3 on this entire denominator, is my answer going to be 2 over 4? No, right? Okay, because over here it is minus sign and plus sign. It is not multiplication. Okay, so that's why we cannot do the division. That's why your n squared cannot be removed. Okay, so it needs to be multiplication, then we can do the division. It cannot be addition and subtraction and addition. Okay, in order for it to be divide. For this 2 plus 3, we can do this numerically. 2 plus 3 is 5, 4 plus 3 is 7. Okay, there are other ways of simplifying when it comes to numeric fractions. Okay, but when it comes to algebra, we need to be clear this is not possible. Okay, so cannot divide by n squared, right? Because n squared is not a factor of n squared minus 2. Okay, so I hope you're clear about that. Okay, so at this point I thought I want to share with you this joke that happened to me when I first started off teaching. Okay, I was also teaching this topic, and then I asked my student, okay, she was quite weak in maths, okay. I asked her a plus b over ab. If I want to simplify by that logic, the G chain S and so on, okay, to remove, right? Cancel, cancel, see same thing, then cancel. Then I asked her, then what's the final answer? What do you think she tell me? She's not that great at that. Okay, she tell me answer is plus and then left with the fraction line. Okay, yeah, so that's the answer, alright? Clearly not sensible, right? Okay, and not logical, correct? So I hope that this helps you remember, okay? When we're doing cancellation, we're actually doing division of a common factor. Okay, so you don't end up getting this kind of answer, okay? So sometimes you're quite funny, so you strange, interesting replies, okay, when we have questions. Alright? Let's move on, okay, to 6.2. Of algebraic fractions. Okay? Always remember that algebraic fractions is an extension of what we do in numeric fractions. Okay? If it can happen for your numbers, it should happen the same way for your algebra. Okay? So we must be very, very good in our numeric fractions. Okay? Don't get ourselves confused. If you don't remember, just try it out on your calculator, see what you get. Okay? Then test your hypothesis. Right? So in multiplication and division of algebraic fractions, something I want us to recall first is how does it work for numeric fractions? I have, for example, half times 3 over 5. How do I multiply half times 3 over 5? I will get 3 over 10. Okay, that's what Jane Xavier says. How do I get 3 over 10? 2 times 5 in the denominator, 1 times 3 in the numerator. Okay, so that's how we do our numeric fractions, right? That's why we get 3 over 10. Okay? So the same thing, okay, that we need to remember is about division as well. If I have half, divide by 3 over 5. What do we need to do? Keep flip change, right? Okay, so we keep this half, flip the other fraction, change the operation. Then we fall back on numerator times numerator, denominator times denominator. And we get 5 over 6. Okay? So keep it change principle, and then numerator and numerator, denominator and denominator. Okay? However, there are certain occasions where I notice students tend to get themselves confused. For example, if I have, let's say, 1 over 6 times 5 over 6. the answer? 1 over 6 times 5 over 6. 5 out of 36, huh? Okay, because numerator times numerator, denominator times denominator. Okay, so that principle, okay, should apply everything. So 5 over 36. Okay, why is it that people get confused? Because they think of addition of fractions. Okay, when denominator is the same, then they forget to multiply the denominator. Okay, so the concept is always numerator with numerator, denominator with denominator. I'm writing it short, denominator times denominator. Right? Then another thing that people tend to be confused by is for division. Okay, what if I have 8 divided by half? What is 8 divided by half? I say 4 already. Say 4? 8 divided by 2 is 4. Okay, but now we have 8 divided by half. So 8 times 4 over 1. Remember, infinite change, and so answer should be 16. Okay, so that tends to be mistakes people make when it comes to numeric fractions. Alright? Okay, so for division, we keep in mind our KSE. Now for we want to simplify the multiplication of these two fractions. 2a squared over 5c cubed times 15c over 8a to the power of 4. Okay? So what do we need to do? We rely on this principle because we're looking at multiplication of fractions. So we just focus on having numerator times numerator first. So 2 times 15, those are numbers, we will get 30. A squared times c. So I'll get a squared c. Okay? So numerator times numerator. Then in the denominator, just looking at the numbers, 5 times 8, that will give us 40. C cubed times a to the power 4, I will get a to the power 4 c cubed. I have a habit of arranging my terms in alphabetical order. If you don't have the habit, you can keep it in whatever order. Okay? And so we apply this concept first. Then now we proceed with simplifying. Don't forget, the question is asking to simplify. Okay? So how do we simplify this? Simplify the individual fraction first. Okay, I don't want us to do that. Okay, you hold on first. I'll address that later on. So from here, what are the common factors in the numerator and denominator? Okay, we can divide by 10a squared c. Right, because 30 and 40, the common factor is 10. A squared and a to the power 4, common factor is a squared. C and c cubed, common factor is c. We always pick the lowest power one. Okay, then we also do the same in the denominator. Right? So our answer eventually will be 3 over 4a squared c squared. Okay? Right? So some things I want to address using this question first. Okay? Xavier was saying that we simplify here first. What do you mean by that? Can you elaborate? A to the power 4. are a to the power 4. There's no a quad. Okay, a to the power 4. Okay, I get where Xavier is coming from. Okay, he might have learned that we observe, okay, where got the same things and then start cancelling around. I don't recommend that. Okay, why? Because you may start to lose track of what you have cancelled. Okay, so I would prefer that you do numerator times numerator, gather everything first. Denominator times denominator, gather everything first. Okay, then it will be much neater, making sure that we divide by common factors. Okay, so that is what I recommend. Right, so that you don't get yourself lost. Especially later on when you deal with more complicated expressions. Right? So by doing that, you might be prone to mistakes. Okay? So I don't encourage that. Right? Then something else that I want to talk about from here to here. Okay, notice that I revert back to this divide by 10a square c over here. Okay, I didn't do the cancellation. If you want to, you can do the cancellation. Okay? So how your textbook in fact displays it, 30 and 40 divided by 10, I'll be left with 3, left with 4. Okay? And then after that, a square and a to the power 4, removing a square, this one disappears, I'll be left with a square here. Okay? C and c cubed, I remove here, 1c, and then over here, I'll left with c square. Okay? I think that is what you may have seen in your textbook or some other books that you may read. Right? But do you agree that with how I write it over here, it is messy? Okay? Messy, right? Because I cancel a lot of things. What if my A don't need to cancel? Okay? Like I mentioned, some of your handwriting can be a bit cramped or very, very small. You may miss out on some things after you cancel. Okay? So it distracts you from certain things, and then after that, your answer eventually becomes incorrect. So that's why I recommend that you use a pencil when you cancel. Okay, so that there is that contrast between your blue or black pen and your pencil. Okay, so that's my recommendation if you want to cancel. Otherwise, doing it in this manner, okay, will be good as well. Make sure that when you do it in this red color manner, you divide both numerator and denominator. You don't just write one unit. Otherwise, it doesn't make sense. Okay, questions? Alright, let's do one more. Looking at part B. Okay. Part B, I have there 3 things. P square over 5q cubed times 35qr over 12p divided by 5r to the power 4 over 6p cubed q square. Okay? So Xavier, you wanted to use the method that you were telling me earlier on. It may get lost over here because you got a division. Okay? Right? So that's why I don't recommend that. Okay? So we do things step by step. Right? Multiplication and division based on our operations rules. We do multiplication first, or rather doing from left to right. Okay, so not do multiplication first. We do from left to right, right? So let's do it. Deal with these 2 fractions here. These 2 fractions will tell me that when I multiply the numerator together, I will get 35p squared qr. And regarding the denominator, 5 times 12 is 16. I'll get p q cubed. Okay? Then I follow through with the division of the other fraction. You can add a conclusion. Alright? So now that we have this, okay, let's not be too quick in trying to simplify this fraction first. If you want to, you can. I'm not stopping you. Right? But like I mentioned, just gather everything first. Okay? So now we have 2 fractions and we're dividing. That means that we're applying this keep and change concept. So we will get 35p squared qr over 60p q cubed times 60p cubed. P cubed q squared over 5r to the power 4. Right? denominators. So 35 times 6, what would that be? 210. Okay. P squared, P cubed, how many P's would that be? 5, right? Okay, so P to the power 5. Q cubed. When I have Q squared, there will be 3 Q's, and then 1 R. Okay. Then we have in the denominator 60 times 5, that is 300. And then there is no P and Q on the other side, so we have just P, Q, Q, R, 4. Okay. Then now, we think of simplifying. What do we divide? What do we divide? Francis, what do we divide? Between 210 and 300, what's the common factor? 5. You think of 5 when you see 210 and 300. That's quite interesting. Huh? 30 P. Okay, I just asking about numbers. 30. Okay. So actually I would think of 10 rather than 5. Okay. So I don't know what made you think of 5. Okay. So 30, 210 can be divided by 30, 300 can be divided by 30. Okay. Then we look at the P. Okay. How many P's we remove? 1. Okay, keep in mind this is P in power 1. Okay, the power of 3 is only to the Q. Right? Then for the Q, how many Q's can I remove? 3. Okay, everything. And then for the R's, how many R's can I remove? 1. Okay, so removing this will stop here. Alright? So now, here we have established what we need to remove or what we need to divide away. 210 divided by 30, I will be left with 7. Okay? P to the power 5, I remove 1 P only, I will be left with 4 P's. Q cubed has been totally removed, so no more. R also removed over here, so no more. So in the numerator, I only have 7 P to the power 4. In the denominator, 300 divided by 30, I will be left with 10. Okay, then P, I removed already 1 P. For Q cubed, also remove. R to the power 4, I only remove 1, so I will be left with R cubed. Okay, in case you're not that good in finding common factors of numbers, right? I have some recommendations for you. Option number 1, let's say just now Francis tell me divide by 5. Nothing wrong also actually. It is divisible by 5. Just that you will not get the simplest form. Okay? So we need to then check and ensure that what we eventually get, okay, can be further simplified. So we got to check. Another way that might be quicker is that these are numbers, isn't it? 210 over 300. Okay? Can you press the calculator for that?